Okay, we've been working with all these radicals and these square roots and rational and all of this because we're getting ready to do some applications. One of those applications is doing the Pythagorean Theorem. Now, this is something you have already done in Math 100. You've probably done this many times. A Pythagorean Theorem requires a right triangle. The legs are labeled A and B, and they are on either side of the right angle. C is the hypotenuse. It is the largest side of a right triangle. This is a leg, and this is a leg. So, your Pythagorean Theorem, and I could go into the whole explanation of how they discovered it, but we're not going to. A squared plus b squared is equal to c squared. In other words, the square of one leg plus the square of the second leg is equal to the square of the hypotenuse. So what happens if we have a right triangle with a leg of 9 and a leg of 12, and we want to know the hypotenuse? Okay. A and B are legs, so we have 9 squared plus 12 squared is equal to c squared. Well, 9 squared is 81 plus 144 is equal to c squared, which is going to give me 225 is equal to c squared. So to undo that square, you have to take that square root, and because it's a measurement of distance, you don't need the plus and minus, so this will simply be c is equal to the square root of 225, and the square root of 225 is 15. Okay? Let's look at another triangle. Okay, this leg is 9, this leg we don't know, and the hypotenuse is 13. Okay, so let's look at that. So we have a squared plus b squared is equal to c squared. The a is what I don't know, so my a squared is equal to c squared minus b squared. And I could do the square root and get a is equal to the square root of c squared minus b squared. Well, my c, a, is going to equal the square root of 13 squared, which is 169, minus my b squared, which is 81. So this a is going to equal the square root of 88. Okay? So, and that is going to be, if we do an exact one, this is 4 times 22. 4 is a perfect square, so that would be the square root of 4 is 2 times the square root of 22. Which would be, that would be the exact value. And I think for you guys, they're asking for exact values. Okay? Okay, we're going to look at the next application of this. And it's going to be in the distance formula that is used when you have 2 points. So it's from the Cartesian coordinate plane, which we've already looked at slope and all kinds of things on this. So now we're going to look at the 2 points on the Cartesian coordinate plane. And it essentially is exactly the Pythagorean Theorem. Okay? So, let's look at this. what do we have here? Well, that's about, looks like it's kind of the same, 3, 3. We'll go with that. So again, here is your C, this is A, and this is B, and here's a right angle. So, what does this give me? Well, this point here would be 3, 0, and this point up here is 3, 3. So what's happening here? Well, the distance from here to here is 3. The distance from here to here is 3. So A is equal to 3, and B is equal to 3. And you can see that if you were to actually draw the lines and everything. So, as you can see, your distance C from your Pythagorean theorem, C squared is equal to A squared plus B squared. So C is equal to the square root of A squared plus B squared. But what gives you your A and your B? Well, in this case, it is your X value gives you your A, and your Y values give you the B. So this would be C is equal to the square root of X sub 1 minus, or X sub 2. X sub 2 minus X sub 1 squared plus Y sub 2 minus Y sub 1 squared. And so now you know your 2 points, 0, 0, and 3, 3. So this would be 3 minus 0 squared plus 3 minus 0 squared. Because here's your x1, y1, and your x2, y2. And this gives you 9 plus 9 square root, gives you square root of 18, which would be 3 square root of 2, because this is 9 times 2. So square root of 9 times square root of 2. This is your 3 square root of 2. So this gives you the distance formula, which is right here. Instead of using C, we'll use the D for distance. So distance in a Cartesian coordinate plane is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So let's look at a couple points, and let's do this. -3, 5, and my second point is 6, 4. X sub 1, y sub 1, x sub 2, y sub 2. Using my distance formula, distance equals the square root of 6 minus a -3 squared plus 4 minus 5 squared. So D is equal to the square root of 6 plus 3 is 9 squared plus -1 squared, which is going to give me 81 plus 1, which is the square root of 82. And that does not simplify. Okay, there is another method we can use to do this. And that is, Mr. Trick uses this method and a lot of students like it, so I'm going to go ahead and show it to you. What he does is he draws a little T-chart. This is X and this is Y. So first of all, we're going to start with our our X2, Y2. So my X2, Y2 is 6 and 4. Minus, and then put in parentheses, your X1, Y1, which is -3 and 5. Okay? Gotta read my numbers right. So now we're going to go 6 minus a -3, which gives you 6 plus 3, which is 9. 4 minus a 5, which is -1. Now you put these in your formula. So 9 squared plus -1 squared, which is equal to 81 plus 1, which is the square root of 82. Okay, let's go ahead and do one more example of the distance formula. And here we are. We're given 2 points, -1, 2, and 5, 3. What is the distance between those points? X sub 1, y sub 1, x sub 2, y sub 2. Using our distance formula first, d equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So my d is equal to my square root of 5 minus -1 squared plus y, now 3 minus 2. Okay, so my d is equal to my square root of 5 minus -1 is 5 plus 1, so this is 6 squared, plus 3 minus 2 is 1, so 1 squared. This is equal to the square root of 36 plus 1, giving you distance is equal to the square root of 37. And that doesn't simplify anymore, so it's the square root of 37. Now let's look at it using the second method. And your second method is using that XY kind of like a T-chart. You're going to look at your second one minus the first, okay? So my second is 5, 3 minus, and then in parentheses, my first one is -1, 2. So 5 minus -1 is the same as 5 plus 1, which is 6. 3 minus 2 is 1. So this is going to be the square root of 6 squared plus 1 squared, which is the square root of 36 plus 1 equals the square root of 37. So 2 different methods. You can choose the one you like best. The first method relies on knowing your formula. The second method relies on just remembering what's going on, okay? So that's it, and that's the end of this lesson. We only have a couple more, and you will be finished with this course. That's kind of good. Okay.